Okay. Good afternoon. My name is Jörg Staub. I'm the head of the technical architecture team at the property and casualty division of Swiss Insurance Company. With me today is Alan Wells. He is in this team and he's an expert solution architect. We are going to give you some insights about our car telematics platform, which is an IoT type of application. The main purpose of the platform is to recognize complex driver behavior and car maneuvers from signals as emitted from mobile devices. We are not using any special IoT devices right now. We are purely using mobile devices. And because we are using mobile devices, there are a couple of challenges to be addressed. First of all, we need to collect GPS data at 1 Hz and accelerate the data at 10 Hz. So there is quite an amount of data that comes together if you look at a large installation with hundreds of thousands of devices. And then there are some areas in the accelerometer space. So for example, when you do left overtaking or right overtaking, you would expect to have only a lateral signals, but due to the sensitivity of mobile devices, you will always have also vertical signals and longitudinal signals. So we need to actually filter that away. And of course, when you look at the mobile phone, it's usually in your pocket or it's somewhere in your car, and when you accelerate, it moves back, or when you brake, it moves to the front or the other way around. So we need to realign the axis before we can do any of the detection. And this is quite a complex math that we need to apply before we can actually do maneuver or behavior detection. The architecture is completely based on Service Fabric and on other platform services of Azure like IoT Hub. And we make full advantage of stateful services, stateful actors, stateless services, and also of the other features that Service Fabric is offering, like the upgradability of individual services, etc. And we are following the Microsoft IoT reference architecture. This is a link to the PDF paper. It's quite a comprehensive paper that we are actually used before we started to actually go into the right direction. I'm going to give you now an overview over the solution. This diagram is missing some of the components, for example, the stateless services which are serving web services and other services that are not so relevant for maneuver detection. I'll start from left to right. As I said before, we are connecting mobile devices. This is Android and iOS to the IoT Hub, so we register them in the IoT Hub. And we are emitting ZLib message back-based protocol because it's very good in terms of latency and size, and it's schema-free. We wanted to have a schema-free protocol. After that, we are using message property-based routing of the IoT Hub to separate, for example, emergency messages from device data messages. Device data messages then are picked up by two Azure functions. On the top, we see the GPS stream, so we actually extract, so we unzlib, unpack, extract GPS data, and we convert it to JSON and publish it to an event hub where we have stream analytics functions attached to it. On the bottom, where we take extract GPS and accelerometer data, and we convert it to AVRO. And the reason for that is when you use stream analytics, the payload of a data window can be of max 256 kilobyte of size, and we need to make sure that, for example, an overlapping window is of size. We have a 3-minute content in there, and we need to make sure that it's smaller than 256 kilobyte. And because AVRO is a binary format, we use AVRO for that, and AVRO is currently the only binary format really supported by Stream Analytics. After Stream Analytics has done the processing, we publish all the data again into event hubs, and then we have our services that actually do the business processing on top of this data. That means, and it's the same pattern everywhere. So we provide data through event hubs to be picked up by services where we do the actual processing. That means we have to implement or have a common functionality everywhere. This is reading data from event hubs and consuming them into services. And as you might know, as opposite to queues, when, for example, when you look at the competing consumer pattern, the queue system does the tracking of the data a receiver has consumed. Then this is different with event hubs. You are responsible for managing the position in the data stream in the event hub yourself. So, for example, when a service fails over or when you restart the service, you need to make sure that you actually reconnect to the event hub at the right position. And we are using, or we make use of the Service Fabric service state in this class, and I'm going to show you the code how we did this. Yes. So we implemented the so-called event hub listener. The event hub listener is very simple to be used and can be used in any service where we need to consume message from event hub. It has basically three methods. There is one to connect to the event hub, and there is one to listen to messages where you can actually specify your method to be called, where your actual business logic is, and there is one to close down the event hub receiver. And I'm going to explain how we did. It's a very nice example on how to use state in Service Fabric stateful services, because the state is very small. This is a really nice example. So here we have a constructor, and because we are using the state of Service Fabric, we need to pass in the state manager. We pass in a logger. We pass in a couple of event hub listener options. This is very simple. This is, for example, the path, so slash messages or whatever. There is the event hub connection string in order to connect to the event hub. There's an event hub consumer group name if you don't want to use dollar default. And there is the partition. So the partition here in these options is the partition of the stateful service. And this is important because we have a one-to-one mapping between service partitions and event hub partitions. This makes the code really simple. Technically, you wouldn't need to do that, but I think it's very well if you do that, because you basically just need to hook up the service partition with the event hub partition. And then we have an offset iteration, and I'll come back later to what that is. So we are going to look at the ensure is open async method. So here we are getting hold of two dictionaries, an offset dictionary and an epoch dictionary. The reason why we are using two dictionaries is because there is different update frequencies on those dictionaries, and you will see why in a second. So we are creating via the message factory. We are creating a message factory from the connection string, from the options. And from the message factory, we are creating an event hub client. Message factory is sort of an anchor class. You can do create, queue listener, topic listener, all these sort of things via the message factory. And actually here is this line I said before, or I mentioned before. Here we are actually connecting. We are using the runtime information of the event hub, and we are connecting the two partitions to each other. So we make sure that the right partition of the service is connected to the right partition of the event hub. And because it's a one-to-one mapping, it's rather simple. After that, if you specify the consumer group, we are going to leverage this consumer group. Now, we are going to get the offset values from the dictionary, and we are going to get the epoch from the epoch dictionary. We see whether we have an offset value, and if we have, we are going to use that offset value to create the receiver. This is here. And now I would like to mention the epoch. So the epoch is basically a phase. So if you have a current receiver with an epoch, and you want to connect a new receiver, you can specify, for example, new epoch +1, and the former receiver will automatically be disconnected from the event hub. So you make sure you really have only ever one receiver if you need to. Sometimes you don't need that, sometimes you want to do something else, but in this case it's really important. If you do not have an offset value, we just use the UTC datetime and create a receiver like this. And now the only thing we need to do here is to actually update the value, the epoch value in the dictionary, and to commit the transaction to distribute the state. The second method is the listen method. This allows you to pass in your function. It's an action, that's a function without a return value, where you actually would put your business logic. So this method gets called when we receive messages from the event hub, and this we do here. And there is also a timer. You have a timeout of 5 seconds. It's a bit balanced. You shouldn't do it too short. You shouldn't do it too long. Because, for example, if you have a cancellation token, you don't want to wait too long until you can actually cancel. If we receive data, we simply invoke our function. Okay. Now the last thing that actually is left to do is to update the offset state in the reliable dictionary, and we do that only if the offset iteration modulo equals to 0. If you specify 1, it would be done every time you receive a message. If you specify 5, it would be done only every 5th time. And this is a balance between performance it's a balance. It's performance dependent. If you do it every time, your performance might not be as good as you want. The thing is, you might receive duplicate messages, but I think idempotency is anyway a good thing to have in your system. Even if you have an offset iteration of 1 only, there is still a chance that you might receive a single message twice. That is basically it. The only thing that we have at the end is, so we catch a couple of exceptions, and we have a close method where we make sure that the message factory and the receiver are closed. So the way we use it, we create event. This is now a stateful service, a service fabric stateful service. We create our options. As I said before, we have an iteration of 5. I need the consumer group name if I have one, the event path, a connection string, and the partition key. That's how I get the partition key from the service, so the partition of the stateful service. I create event hub listener. I call ensure is open, so I make sure everything is wired up, and then I call listen async, where I specify my method to be called in terms when data is arriving on the event hub, and this is the actual implementation of the business logic. Okay, yeah, I've done that before, and now I'm handing over to Alan Wells. Please, Alan.
Okay. So thank you, Jörg. As you can see from the architecture diagram, we're using Stream Analytics extensively to process and shape the data as it's coming through the system. So what we have are 3 different Stream Analytics jobs. One is for the session end detection. One's a tumbling window, which is going to process the GPS data. And then the other is a hopping window, which is going to be working on the GPS and the accelerometer data. So what I want to show you now is actually how we do this in Visual Studio. So a new feature of Visual Studio is that you can download Stream Analytics extension, which will allow you then to develop these kind of queries in Visual Studio, and also you can run them locally and then submit that to Azure to see it actually working with real event hubs. So here for the hopping window, what we're going to do is we're going to collect the data from the device, and we want to bucket it into 2.5-minute windows. And this is important for the maneuver detection algorithm, because we need to know if a maneuver happened inside that window or whether the maneuver happened in the window just before it. So what we do is we partition by the partition ID from the event hub, then we're going to group it by the device ID, device type, and then generate that hopping window. So what we can do locally is that we can specify an input JSON file, which is going to look exactly like the data that typically goes through the event hub. And here we can support the JSON format. Avro is coming, so normally with the hopping window, we would actually use the Avro format in production, but for local development, we can provide this static file. So what you do is you typically start a new instance of the debugger, and this is going to launch an emulator which is going to work exactly like Stream Analytics works in Azure, but for local development. So we've fed that input data file in, and what it's going to do is process that query that we've written, and then it's going to write the results out. So you can see inside Visual Studio that we have the results here. So we have this ID, which is representing a specific device, and the specific window, and then that collected data will be processed later by the Event Hub receiver, which will put it to the place that it needs to go in order to process it. Now, it's not just shaping data that we use it for. We can also use Stream Analytics to generate new insights into the data. So here what we're doing is we're going to be basically doing a left join on the data stream as it comes in, and it's going to tell us if a device was sending data, and then 10 minutes later, the device has stopped sending data. So this is a very nice way to achieve a very difficult problem, because Stream Analytics in the cloud is going to be managed for us. So the scaling is going to be managed for us, availability. We just tell Stream Analytics declaratively how the code should look, and it will execute it. So very similar to what we did with the hopping window, I can launch the emulator, I can make changes to my script, I can let it run, and then I can see the output that it generates. So the output here is telling me that there are 4 different devices that have stopped sending messages. And I think this is a very nice feature that's come with Visual Studio. And you can actually also use it then to submit it directly to Azure and then see real data going through the real Event Hub. So that in a nutshell is how we do the Stream Analytics processing. I'm going to pass this back to Jörg now to wrap it up. Thank you.
So, okay, I mean, in this session we showed you a common class that we are using to receive messages from Event Hub. We showed you that we are using Stream Analytics to group content into time windows. And by the way, we are using the timestamp of the device. We're not using, by default, it's using the in-queue timestamp normally. We are using the real timestamp because that's what we want. Alan showed you how to run Stream Analytics shop inside Visual Studio. And we also told you that we are using mobile phones and we treat them like IoT devices. Now you still have 2 minutes left for questions. Anybody? Yeah.
2 questions. First, did you use any
Can you?
container in this solution? And second question, did you have any workaround for the offset that you're keeping in the state manager? What if the whole system goes down? How do you recover?
Okay, can you repeat it, Alan?
Yeah, so basically, are we using containers on Service Fabric? And also, if the system goes down because it's in a reliable state, is it a volatile state? Is it persistent? What happens? How does it restart after that?
I mean, we are using the state inside Service Fabric. So Service Fabric keeps track of, provides the functionality to distribute the state at least across 3 replicas. And when we restart or when we would reinstall a system, we can actually take a backup of this state and redistribute or reinstall, redeploy the application when leveraging the same state again. So Service Fabric is doing that for that. Because the state we use persistent actor, the state is actually ending up in storage accounts. I hope this answered the second question. The first question was?
Are we using containers for Service Fabric?
No, we are not using containers yet. We're using pure service. As a Service Fabric doesn't have a container format in that sense, but it's actually an orchestrator of EXEs as it is today. And as we heard this morning, Service Fabric will also work with Docker containers. So it will become a full orchestrator, not just for EXEs, but also for Docker containers. And this will be this will be offering a lot of new scenarios where we could use Service Fabric. Yeah.
Thank you.
29 seconds left. Last chance.
Is there a particular reason you guys didn't build service fabric specific listeners? Like you have a listener, but it's just your own class that you involve manually from run a sync versus actually building an instance of service fabric stateful service listener and bootstrapping that in create listeners method.
Yeah. So I think basically the difference between event hub processor and event hub listener, right?
Yeah, I mean, we are not using any on all the stateless and stateful services, we are not using any iCommunication listener type interfaces. So we are not calling the services directly. That's the design principle, at least as of now. We are only consuming events from Event Hub for services. For Actor it's different because Actors, they provide an interface. You know, Actor, you call them, you implement an interface on the Actor level. But services are only, they only consume messages from Event Hubs. So they're completely asynchronous. They do not provide an external call API. I hope. Okay. Thank you very much.
Thank you.